Okay, this video has two example problems where we're using X to determine equilibrium pressures or concentrations. So the first thing we're going to do is we are going to write the balanced equation. So PCl5 in equilibrium with PCl3 and Cl2. And then what we're going to do next is set up our initial change equilibrium chart. We're going to draw a fence under the arrow. Now what I'm going to do is go back and read the problem. So we've got this equilibrium that I've written here. They're all gases, so it's a homogeneous equilibria. They've given us an equilibrium constant Kp that has a value of 0.497. So if I were writing the expression, it would be Kp equals the pressure of, sorry, this should be PCl3 times the pressure of Cl2 divided by the pressure of PCl5. Those are all raised to the first power, and Kp is 0.497. We will come back and we will do something with that in a little bit. Okay, so now what we're going to do is we're going to continue reading. 500 Kelvin has an initial pressure of PCl5 of 1.66 atmospheres. Whoops, sorry about that. Now, it doesn't tell us anything about PCl3 or Cl2 initially, so these are both 0. Okay, because our products are 0, we know that the reaction is going to shift to the product side, because all we have are reactants. We don't have any equilibrium pressures, so that tells us that we're going to use X for our change. So our reactants will go down by X. Our products will go up by X. All of the X's have a coefficient of 1 because that matches the coefficients in the balanced equation. And then on the equilibrium line, if I subtract here, I get 1.66 minus X. If I add here, I get X and X. Okay, now what I want to do is I want to substitute into my expression. So I'm going to use 0.497 equals PCl3 and PCl2 are both X's, so that's the same as X squared, divided by 1.66 minus X. Now, to solve, it's like that 0.497 is over 1, so I am cross-multiplying. So what I'm going to do, I'm going to go to the next slide. 1.66 times 0.497. Okay, so what I will have, I didn't want to go to the next slide. Let's go back. Okay, so I will have 0.82502 minus 0.497x. That is equal to x squared. So if I move everything so it's on the same side, I will have x squared plus 0.497x minus 0.825 equals 0. Okay, so now I need to do the quadratic, which is x, whoops, I didn't want to do that, sorry. All right, x is going to be equal to negative b. So b is 0.497. I got to remember this. 0.497 negative 8.25. Okay, so negative 0.497 plus or minus the square root of b squared, which is 0.497 squared, minus, Sam, those sevens are for you, 4a was 1, c was a negative 0.825. This is all divided by 2 times a, which was 1. I want to go back and make sure that I have those numbers right. My 497 is positive. My 825 is negative. So, yes, so now I'm going to solve. X is going to be equal to, okay, so we get whoops, my color. We get 0.693 or a negative 1.19 for X. So we're going to go back and we're going to substitute X into those. This is the important one to look at because we had a negative 1.19 and we can't have negative values for either one of these. So that tells us that we are not going to use that one. So we're going to use 0.693. So if we remember, PCl3, pressure of PCl3 was equal to the pressure of Cl2. Those were both equal to X, so those are both 0.693 atmospheres. Pressure of PCl5 was equal to 1.66 minus 0.693. So if we do that, 1.66 minus 0.693, we get 0.967 atmospheres. Now, what we should be able to do is take these numbers and stick them back into, didn't want to go that way, sorry. Stick them back into our expression. So both of these were 0.693. This was 0.693. PCl5 was 0.967. And if I do the math, 0.693 squared divided by 0.967, I get 0.497. So that confirms that we did this one correctly. So let's go ahead and let's go on to our next problem. So we're going to follow the same procedure on this one. We've got our balanced equation. So I've got hydrogen gas and iodide gas in equilibrium with 2HI gas. I'm going to set up my initial change equilibrium table with the fence under the arrow, and I'm going to substitute in what I'm given. So I've got a 1 liter flask, which makes determining concentrations easy. I have 1 mole of hydrogen and I have 2 moles of iodine. Both of these are divided by 1 liter, so that gives us 1 molar hydrogen and 2 molar iodine. I'm not given anything for hydrogen iodide. If I read the rest of the problem, I see that I have an equilibrium constant that's 50.5. So Kc is equal to the concentration of Hi squared divided by the concentration of H2 times the concentration of I2. These have coefficients of 1, so they're raised to the first power. Hydrogen iodide is squared because it has a coefficient of 2. So I'm not given any equilibrium concentrations. That tells me, because I have this Kc, that I am going to use X. So the reaction is going to shift toward the 0, which means hydrogen iodide will go up and hydrogen and iodine will go down. So these both have coefficients of 1. They go down by negative X. Hi has a coefficient of 2. It goes up by 2x. And then my equilibrium line becomes 1 minus x, 2 minus x, and 2x. I want to substitute into the expression. So 50.5 equals Hi, which is 2x. Remember, that whole quantity is squared. I'm dividing that by 1 minus x times 2 minus x. And that's the 50.5 is like it's over 1. So I need to do some math, and I'm going to have to factor. So let's do the factoring first. So that will give us, we're going to have 4x squared over 2 minus, we'll have a negative x and negative 2x, which will be negative 3x plus x squared. So what we want to do is we want to take this, and I'm going to put it on the next slide. Okay, so the 50.5 is like it's over 1, so I'm going to cross multiply. So I will get 4x squared. I'm going to get 110 minus 151.5x plus 50.5x squared. I like my x squareds to be positive, so I'm going to subtract 4x squared from both sides. That'll give me 110 minus 151.5x plus 46.5x squared. Just as review, this is my A, this is my B, this is my C. So I need to substitute into the quadratic. So I'll have x equals opposite B, which is, now this is negative, so that means my B will be positive, 151.5 plus or minus the square root of B squared, which is negative 151.5, that's squared, minus 4 times A, which is 46.5, times C, which is 110, all divided by 2 times A, which is 46.5, and now we need to... Okay, so when I solved, I got 2.165 or 1.092. If I go back, too many. If I go back and look, if I use the larger of those two numbers, I'm going to get a negative number here. So, let me make sure I've got a different color. Sorry, I can't remember what it is, 2.165. If I substitute 2.165 in here for this x, I am going to get a negative number, and I can't do that, so I've got to go with the 1.09. So my concentration of H2 is going to be 1 minus, oh, I did this math really, really bad. Something's wrong. Okay, so I just said something was really, really wrong because I knew I was going to get a negative here as well with both of my numbers. So that tells me that these numbers were not correct, and I need to go back and I need to redo this math. So when I do that, and I do it correctly, the two answers I get are 2.323 or 0.935. I'm sorry about that. I don't know what I did. Okay, we already know because we talked about how the one that was larger than 2 was not going to work because that was going to give a negative number here. So we're going to use the 0.935. So my concentration of hydrogen is going to be 1 minus 0.935, which is going to give me, and I want to do, let's go back and look, 3 significant figures. So my answer is going to be 0.0650 molar. My concentration of iodide is going to be 2 minus 0.935, which is going to give us 1.065. I want 3 sig figs, so 1.07 molar. And then my concentration of hydrogen iodide is 2x, so 2 times 0.935, and I get 1.87 molar. So these are our answers here.